Recording now. All right, so this will be a quick, very brief where we came from on this. This is part of the Science Olympiad. This is a trial event. This first year we're doing this in North Carolina Science Olympiad. My name is Tom Divick. I'm a teacher and a programmer. I'm chemist and programmer when I first started, then continued to program, and also taught engineering at Charlotte Latin School for more than 25 years. All right. We are talked about what an Arduino is, a microcontroller, an open source microcontroller. It comes in all kinds of various formats, including the breadboard that you've gotten with your kits. And we use it in everything from 3D printers to quadcopters. We use microcontrollers. Then we reviewed the hardware on this. We talked about the different parts on our Spark board. Also be the equivalent of an Arduino Uno if you've got an Arduino Uno. Same type board. And we break it up. We do have a power jack. Generally we use the power right off of our computers. On a Arduino Uno, the one difference is it uses the standard printer cable, USB printer cable. On a Spark board, it uses USB Mini. All right, it's not quite as small as a micro, but it's a mini port. And it hooks up to your computer, and that's where it gets its power, and we can program it. And that's what makes it different. We have power pins on here. We power up both our projects. Usually we use this associated with a breadboard, and this is how we can run power to our breadboard. And then we have things like, she's not like, we have analog pins and digital pins. We talked about the difference between analog and digital. In terms of digital's on and off, analog is a range. Okay? Please raise your hand if you got a question. And in an ideal world, I would have, we could meet 2 or 3 times a week, take as much time as you wanted. I could stop the webinars, ask lots of questions, keep you very involved. Unfortunately, this is not the real ideal world, and therefore I need to cover this material. So I'm going a little bit faster than I normally would ever if I had the time to do it the way you would like to do it. But I also know that you all are very busy. So please raise your hand when you have a question. If you don't understand it, there's a very good chance other people haven't. Also, let me mention again, I've also included on those Google Docs Scratch and how to work through a Scratch curriculum. So if you've never done programming before, that wouldn't be a bad idea. All right, Scratch is very accessible, developed by MIT, and before you look at it and think it's only for kids, Harvard freshman programming students start with Scratch. And my guess is Harvard freshman programming students know something about programming. All right, now, as we go back to our hardware here, you can see we even have lights here. If the TX is for transmitting and the yellow light is for receiving. Because part of what we're going to be doing in this contest is troubleshooting. So we need to be able to recognize these. There's pin LED 13 when we want to just blink an LED on our hardware. There's the on and off light down here. And we asked these questions. We talked about a breadboard and how breadboards worked. Talked that they connect horizontally here and up and down these buses. We then talked about the incorrect and correct web placement. That if you basically want to go now, if these buses go vertically, you want to place your components horizontally. If they go horizontally, we want to place them vertically. Then in this case, so this is a perfect circuit coming off the ground into the resistor, into the short leg of the LED, because LEDs definitely are sensitive to polarity. Long leg, the anode. And the LED with the bend in the wire represents the long leg back to the positive pole. Okay? And there's an anode, cathode, and LED. We talked about that in resistors and simple circuit. This time we're also using, and you've got to use something like either Chrome or Firefox, and we use 123D Circuit Simulator. Have that out again tonight for those people who don't have their SparkFun kit so they can practice with it. Now, we ended up learning how to use this software, and it's pretty straightforward. There's only a few keys in it. And rotating R being probably the most important one. You click on it and they're going to change colors. Again, to learn how to do that, just watch the other video. We've got to get moving tonight. All right, and then what we did is we used our breadboard kind of just as a battery source. And so we hooked up, came off the 5 volts here, the ground here. Then we ran another ground wire across over to here. Changed our resistor, set it to, in this case, 330, and changed the color of the resistor in your kits. There it is right there. Notice we're going to, as the current runs through here, it has to go through the ground. Okay. Here's the LED. Remember, if it's in the horizontal, the LED can't be in the horizontal. We need to move it in the vertical. So we rotate it through. Ground is connected to our resistor. So this is the cathode, I should say, and there's the anode. And we connect it back right here. And when you run the simulation, your LED light would come on. And there it is. A little yellow light. And then real briefly, we then sat through and tried to set up our LED right there. Came off, there's our 5, there's our ground. Remember one point we tried to make for this, particularly this class, that you're always going from higher potential to lower potential. This is true with electricity. And so we're going from 5 volts to a ground of 0. And so you've got to always figure out, for what we're doing, hey, where's the ground? If I'm going to have 5 voltage, where's the ground off that? If I'm going to have and another thing we're going to always keep in mind, if we have an LED, where's the resistor? All right? Or we might fry or burn up some of our LEDs. So this 5 volts goes up this bus here, goes to the positive side of the LED. Then the negative side of the LED goes back to this resistor, back to the ground, going back to the breadboard. But the breadboard is acting like a battery or just a power source. The computer's really not doing anything. And then what we did is, using 1, 2, 3D circuits real quickly, we demonstrated how if you ran the ground over here, ran our LED up here, ran from the ground to the resistor again, to the LED, but this time we came back to pin 13, we could now control the light, besides just us plugging the lead in there. Lead are these black lines. And we went up, and we clicked on upload and run the code. Blinking an LED, for those of you who have had programming, is the equivalent of hello world. And we got the LED to blink, hopefully, on your simulation. And this is it on a Spark board or on a Breadboard, or on a, if you would hook up an Uno, you could do it the same way. Any questions up to this point right now? That was a 10-minute review of what we did last one. Remember too, this is a good time to point it out, we're going to have a webinar tonight and the next 2 Wednesdays. And then we'll pick up again on January. We can figure out what's the best days for folks. All right? Real quickly, of those people, how many people have a Spark Fun Kit by now? Raise your hand if you or your school has a Spark Fun Kit. All right, excellent. There are books, there are tutorials you can start working on. I'm going to post things far enough advanced that you can always work ahead too. All right? I'll put everybody's hands down. Leave them up. I'll put your hands down when we do those. Real quick. Real quick poll here. Did you launch the PDF before tonight? How many people actually downloaded the 2 PDFs? If you'll just answer that survey for me, that'll be great so we get a better sense. It's fine if you didn't. We're trying to get you in the habit of it. I just need to poll it so we know. We can learn. All right, we got 83% voted. 5, 4, 3, 2, 1. Yes, John. Okay.
I don't have a question.
Oh, okay. All right. Well, I'll meet you back off. I thought I saw a hand up, but my mistake. Sorry. Okay. Now, what I would like to do today is this time, since we have, many of you do have your SparkFun with you, we're actually going to go ahead and not do it virtually, but we're going to hook it up. We're going to hook up our software, and we're going to try to do it. By now, I hope you've installed the Arduino software. If not, you go to the Arduino's website, and they'll go under download, download the software. You can also, in your SIK guide, your SparkFun guide, they have a step through to download all those examples of their code. I'm a little hesitant of having you do that right off the bat, because don't make this mistake that students sometimes make. Oh, I don't want to type all this code. I'll just copy it. Copying the code doesn't mean you understand it. Frankly, typing out the code and just making it run is only the very minimal understanding. You understand it when you start making code, writes code to do what you want it to do. And you're going to get a chance to do what called LED sculpting over here for a little bit later here, where you turn the lights on and off, and you can make them look really pretty, and we can change the order. That's when you understand your programming, when you can make the lights do something that I haven't even mentioned it in class. Okay? By the way, here's the results on that. Again, only about 20% have downloaded the PDF. You might not have needed it, but it is there. Okay. So, when you install the software and run it, it looks like this. In case you're curious where you might go to it, just search real quick, do a Google on Arduino. I think it's .cc or Arduino open source microcontroller. Go to the software and hit download on that. Since people seem to have done a lot of it last week, I wasn't going to spend time and actually going through the download. If that is an issue for you, you don't have the software, you can't get it installed, please, I'll stay after class to help you. Sometimes the drivers can be an issue. All right? And if anybody has a problem that way, let's do that after class. And for now, you can use the Circuit 123D software if we need to. Okay? So this is the Arduino software. And many times you go in File, Open, and you can go in, and there's lots of different. Blink is always a classic in physical computing, getting an LED to blink. But they have motors and different things that you pull in there. But what I would tell you is under Sketchbook and Examples, they actually have tutorials if you want to work your way through them. All right? And on the Arduino webpage, if time permits, we'll go to that tonight, and I can show you. And we've got links to it already, but there's a lot of tutorials there as well that you can be working on. All right, and here's some different menus. I would say this menu is an important menu for both the board and serial port. And your board, in this case, Arduino Uno will work for on the SparkFun board. All right, that assumes what board you have. That's not a bad place to check to make sure it was hooked up properly. All right, the next thing you might have is serial port. On a Mac, you're going to look for some type of thing that says, for example, USB inside of it. You probably want to avoid any of the choices that say Bluetooth. In the Windows world, it's usually COM3 or COM4. Don't worry about programming it right now, that program right off the bat. And so here's, for example, if you go through the menu choices, here's example, basic, blink. All right, so those are different examples we can use. Here comes a blink right here. So if you would, let's go ahead. All right, what I want you to do right now is go ahead for me, go under examples, select basics, and select blink. Raise your hand once you've done that. If you are going to be using the oh boy, long day. The circuit software, circuit simulation software, then just raise your hand and say you've got it as well, because that way we don't have to wait on you there. You're never going to be ready. But if you're using your Spark board, go ahead and bring up the Arduino software if you can, and bring up Blink like this. And then raise your hand so we know that you're ready to go. When I get past 70%, I will go. And I think we're now at that point. So we're going to go ahead. You've got that. What I'd like you to do then, do File. Once you brought up your Blink program, it's going to look something like this. Go under File, Save, and save it as Blink Your Name. Because you don't want to, the original code, you don't want to mess up. If we change things, it doesn't work. Hey, it's not the end of the deal. Once you have that, you can also, if you would, set up your hardware to look like this. Since your hardware may not have been set up, set your hardware up like that for right now, please. So you're doing, so we're going to have our hardware looking like that, but let's go back down. What I want you to do, again, let me say it, I kind of rushed that. Save this, bring this program up, hit File, Save As, Blink Your Name, so you don't replace the original software. Once you've done that, I'm put everybody's hands down, then hook up our hardware. Erase right up here. Okay, let's hook up that hardware. Remember, use this color resistor. They have 330 and 10K. 10K has a high enough resistance. Your LED is going to look at that. And just a quick, I'll let you work on that. I'll ask the next question in a minute. Raise your hand once you have your hardware hooked up and the software, okay? And hardware is drawn out on the, physically done like this, or in the circuit 123D. You have that ready to go. Like I say, when you got yours done, please raise your hand. If for some reason you can't get on circuit 123D, and you don't have the SparkFun software, your school's got it at school, a different student has it, etc., then just raise your hand so we're not waiting on you. Because as we get doing this, I'm waiting on everybody before I proceed. All right. So with that in mind, okay, great. I'm putting everybody's hands down. So. But students, I really suggest that we you have the hardware in the future, and so you can actually program some of this stuff. Or you're doing it with that simulation. If all you do is listen to me, you're not going to get nearly as much out of this. All right? And I do appreciate the fact you're out here on Wednesday night with everything else you have doing to work on this. But I hope you also find this really interesting, because there's lots of really wonderful career opportunities, and it's truly fun to create things from scratch, to create your own stuff, not just put a kit together. And this will allow you to do a lot of building your own things. Go on SparkFun and Adafruit just to see the different kinds of projects people are doing. Okay, so let's look at our code up here. And what this code does, let's go through it right up here. I'm going to highlight up here. All right. The top of your code would say something like /*//, and this is comments. Many of you have had programming before, so this is how we comment. For those who haven't, comments are a way for us to write a note in the code so we can read it, but the computer's going to ignore it. We can't stress enough that you can probably never put too many comments on your code. If you're going to err on the side of too many comments, not too much. All right. So anything between the /*/ and / is ignored. All right. So I can write in English here. If I didn't, the computer would try to figure out what I'm doing and would give us an error message because I couldn't do it. Okay. Here's how we define a variable. int means integer, and that's just whole numbers, no decimal points. The variable name is LED pin, and then we have 13 there. And what in programming it's a little bit odd. We don't read left to right like we usually think. A lot of times we're reading right to left. And in this case, what we're saying is there's two parts to this, as you're going to see. First, we're going to make a variable. It's going to be an integer. That's the green. The variable name is going to be LED pin. Is it case sensitive? For you folks that know some C programming, is C case sensitive? Raise your hand if you think it is. All right. For those new to programming, let me tell you, it is case sensitive. And you will find in this world that if you go on into programming or engineering, that they have standards at the company. One of the common standards out there is the first word is lowercase, this next word is then uppercase of the first letter. So this is LED pin. We don't like spaces necessarily in our variables in a lot of instances. So we combine the words, but the way so you know you're starting a new word, we make the first letter caps. So we make a variable called LED pin. Sorry, sometimes go to my web. And then we take the variable 13 and we're going to assign it to LED pin. This also happens to be the 13th pin on our Arduino. Remember, if we look at our Arduino, let me go back up here real quick. Let's go to here. We're going into pin 13. See it right there? So that's pin 13. So we're on pin 13. And then, just so you can see, semicolons. All right, we don't have semicolons everywhere, but many times we do. We'll talk about the times we don't in just a moment here. Now, we have void setup. In the back of your mind right now, remember, to ever run a sketch, which is the software they call in Arduinos, you always have to have the setup function and the loop function. And they begin with void. And void is, what is void? It's basically saying this function is not going to return a value. So we have void setup, parentheses, parentheses, and then the left bracket and the right bracket, or I'm just going to refer to them as containers, because that's what they do. Everything where this begins, after this left container starts, all this code goes in, and then you have the right container. All right, I know on your keyboard it's not called a container, but I want you to think about it that way. So we have a void setup. It's a function, so it has parentheses, a container, container. Notice there's no semicolon after here. Look down here, you're going to see another function. It does have a semicolon. Why do these two lines not have semicolons? Why do these two lines right here, initialize the digital pin as an output, pin 13 as connected of Arduino boards? Why do you think they might be? Do they look like computer code or do they look like an English statement? Just raise your hand if you think you know. Trying to get students here. All right. Okay, let me ask. All right, Hayden, what's going on there? Hey, Hayden. If you have to, write your answer if you can. Hayden, I don't know why, but I'm not hearing you, so maybe your mic. Howie, what's going on? Howie, I can whisper. Why do you think? Why do they have the slash? Why do these not have a semicolon after them?
Because that's a comment.
Very good. That's exactly right. Those are comments. These are not computer statements. These are comments, so we don't have to worry about it there. But after this output one we do, and up here we're using brackets. Okay? Now let's go on to the next bit of line of this code. Void literally means, by the way, no value. All right, so what is setup? That's one of the two functions you always have to have. Set up a function which starts when the program is run and initializes variables. Sometimes we can use that, set the pin, starts using the libraries, etc. We can do it different things there. All right? But it's a required part of the program. You can't even run a blank program without it. So you always have to have setup function. You always have to have the loop function. Put everybody's hands down here. Okay. All right, and then the curly brackets. Inside these brackets is where the code goes, but what about the lines inside? You just said those are command lines. All right, now here's another pin mode, and notice there's no void. This is not a void on this one. All right, we're going to do something with this. We got a question down here. Let me go ahead and get the question. Hang on 1 second. Yeah, kind of like a main method, yes. Okay, now here's pin mode. Notice, look at this, even in the functions we follow that pattern where the first word is lowercase, second word is uppercase. All right, when they're Arduino functions or sketch functions, you have to spell it and cap it just that way. It won't read it any other way. Your variable up there, LED pin, you could ignore those rules, it'd still work, but in this case it has to be this way, lowercase pin, uppercase mode. And it's saying, you're giving it two arguments here. LED pin and output. LED pin is saying the pin you're going to, and you're going to make it an output. We've all had enough computer experience in here, I suspect, that we understand that computers are very stupid. They're stupid as sticks. I've offended sticks everywhere. A computer does what you tell it, not what you want. And so we have to tell the computer, hey, pin 13, we're going to make it an output. Right now you're saying to yourself, Mr. D, I do not see pin 13 anywhere here. But remember we said LED pin, we made a variable, and let's go look right back up here. Ah, there it is. LED pin is 13. So as far as the computer is concerned, LED pin is 13, and what we're saying is make that pin on Arduino. So there's pin mode. Go to pin 13. There's our semicolon, and make it an output. Because it could be an output or an input. LED is an output. A touch sensor is an input. All right? Any questions on this? You can get it to run without defining it as an output or input, but here's a little tip for you. If you don't tell it as an output, but you still turn a light on like we're going to in a second here, it won't come out at 5 volts. It comes out at 3 volts, I believe. So if you want to get the maximum value out of that, make it an output. Does that make sense, everyone? This will make a little more sense, too, once we get the code going, that you can see what's going to happen here. All right, now, and there's our semicolon, and you'll get that error message the minute you don't have a semicolon. All right, so this is your code so far. And you could be writing this from scratch, or you can be using the existing Blink program that you did, and we're just recopying and changing the code a little bit. I don't care which way you do it this first time through. But down the road, you need to try to make this happen without just copying the code and seeing in your head, okay, what do I need to do to turn it on? So here's a comment to tell ourselves what we're doing. We defined this pin. Those of you, since you've had some programming, the scope is such that if we define the variable up here, this variable will last throughout the whole program. It's seen by all the other functions, right? Now, void setup, there it is. It says, hey, make pin 13 an output. Now, I do this when I'm teaching kids. Whenever I teach Arduinos to begin with, we'll use Scratch and we'll loop through things. That's the next function. It's just like this in Scratch. Let's move on, since many of you have not done Scratch or you're already doing C. So the next function you have to have, if we had void setup, is void loop. Here it is. There's void loop. And a new function, digital write. Oh, wow, we're going to digital write. What pins are we using right now, Mr. Dubik? We're using a digital pin right here where we're hooking up to this thing. So we're going to be hooked up to pin 13 right there. That's all the digital pins right here. So if we're going to talk to a digital pin, we're going to make it digital write. But it's going to be either high or low. See, all its digital is. Digital is always yes, no, high, low, true or false. In this case, we use high, low. Okay? So you're saying in void loop, digital write, parentheses, LED pin. What does the LED pin represent? Again, 13, make it high. Next line down is going to delay it for a second, 1,000 milliseconds or a second. Digital write LED pin low, delay a second. There it is. LED pin, which is 13, we just said. There it turns the LED on and then turns it down low. For in this class, for practical purposes, for what you're trying to do tonight. And then delay 1,000. So your code is altogether is looking something like this. LED pin 13, void setup, void loop high, 1,000, pin low, 1,000. So the functions you learn pin mode. That can be an output or an input. You found void setup, in the function. Then we found the function pin mode. Then we had void loop. Again, look at this. It's another. This one has a container, left and right. It also has the, just like in pin mode, has parentheses. By the way, it has a semicolon. In the void loop and the void setup, you have parentheses, but then you have these containers, and they're all contained inside there. Any questions on this so far? All right. I had most of us paying attention. Now, here's the next thing I would like you to do. Either on your program or on the 123D circuit, I want you to go ahead. If you click on this click first here, it'll compile it and tell you if there's any error messages. And then if you click on this arrow here, it'll allow you to upload it. I like to compile it first because I want to see if there's any typos or mistakes in my code. Then I like to upload it because sometimes I have a problem uploading it and I'm thinking it's in my code. I want to immediately isolate the two. So if I compile it, no error, then I go to upload, it doesn't upload, then I know it's probably in my hardware. All right. Go ahead, upload it. You should know the light blinks. And then, if you would, make it so the light blinks quicker. It's a faster blinking light. What would you go ahead and change on it? So what I need everybody to do now is go ahead and see if you can get your light to blink, be it a physical light or the virtual light, using some of the code we're using now. I've left the code up. I'll tell you what, I'll leave the code up right here so you can see it. I'll make it a little bit bigger here. Let me see if I'm going to lose my screen if I do that. Great, I'm not. Okay, great. You all can look at that. Raise your hand once you have a blinking light going on. Excellent. And again, if you don't have the hardware, try to use the 123D circuit. You go on Chrome, you go on Firefox, you don't download anything, you log in your 123D circuit and try to do this. Another tip while listening while we're doing this. Write code, make a light blink at school, get your friends to look at it, and then change something so it doesn't work and have them troubleshoot why it's not working. I.e., you don't run a lead back to the ground. Or maybe instead of saying pin 13, you change it to pin 12. All right. Also raise your hand if you're not going to be doing this right now, so we're not waiting on somebody that has no intention of physically doing it. When there's lots of reasons why you might not be able to, we understand. Hopefully, though, you're going to get a lot more out of these webinars if you go ahead and bring the hardware or do it virtually. You can write questions. If you want to jot a question down for me to look at, happy to do it. Okay. All right. Now, let's go because time is definitely a challenge for us here. We got more than 80% of you have now said they've got it or can do it. So we're going to go on. First of all, let me just say this. Writing and programming, it's very normal and many of you who've been programming already know this, that you have an error in the code. It's not a big deal. Finding those errors, you'll get better and better at it. And honestly, that's part of the competition. Secondly, you have Arduino's troubleshooting guide is right there. You also have, as far as what we're doing in here, the PDF and the recorded webinars going on. Okay? Now, if you've been able to make it blink faster, can you go, here's something, I'll leave it up now. We're going to move on, but here's something for the teachers to give the kids to do. Kids, if you want to challenge each other, can you make it do these things? Can you make the light lines go out linearly faster, slower? Can you use Morse code? Could you use a variable with the delay? We say 1,000, but could you make that a variable? Could we do mathematical calculations with that? So that's all something you can do, all right? Now, let me give you another thing you can do. There's a webinar tutorial. I've already got it placed there. The official Arduino tutorial homepage. If you never programmed before, try Scratch. And Scratch tutorials are already posted now up there, so we have those. Okay? We'll do some more live webinars at. Now, I want to go to the next lesson on this, lesson 2. All right? And in this one, well, we won't get done. We're going to be doing well to get through lesson through Christmas. Now, if you're all worried about, wait a minute, we got to get 10 lessons before the start of webinar. We said 10 webinars, not necessarily 10 lessons. All right? These upcoming lessons, too, will be more of a focus on software than hardware. So we're going to get it so you can program it. And for those of you that have got some programming experience, probably can pick this up much faster. And that's fine. Someone on your team could be more of a hardware person. And you're going to find many times software, and some people tend to like software, some people tend to like hardware. All right? So, moving from controlling 1 to controlling 8 LEDs. And that's really going to be our goal. All right? Again, a review hardware and software. We just did this, but everybody knows these are an LED. What's the longer leg of an LED do? That's the longer leg connects to the positive, allowing the current to flow through and ultimately allows the LED to light up. All right. Now, when we looked at these, when you have multiple ones, we can all share the same ground. They're all coming off of different pins, and that's an important part. These are called resistors. I'm going fast again. Pardon me. And voltage and current. Okay. LEDs are so darn efficient. If we didn't use a resistor, we would burn the LED up. Okay. And you will find that when you accidentally put an LED in there and you don't put a resistor, the LED will get real bright, maybe smoke, and then it will never come on again. All right. And real quickly, as we're going through this, I would ask you what some of these are. So, where are the digital pins? Where are the analog pins, the power pins? And no, we didn't tell you in the last one. C is where we find the ATmeg chip. That's really the computer on this board. All these other ways are hook that chip in there. So, take a quick second, see if you can figure this out. Again, we've just been talking about this, but there's a real quick review. Digital pins, analog pins, and the power. Okay. We just talked about this with comments, multi-line comments. These brackets are containers. I am so sorry, I'm getting this. Void setup and void looper anytime we do a sketch program, okay? So right now on a sheet of paper, if you can, somewhere you write down, I want you to create a variable named LED pin again, and it's going to store an integer 12. How would you do that? Once you have it, raise your hand. And if you want to write me down as a question or comment and tell me, that'd be great. Luke's got it. Excellent. While you all doing that, I'm going to do another. How's the pacing been so far tonight, folks? Okay. A couple more people want to vote. I'd appreciate it. I'd like to try to get the votes over 80%. But we're right at 79. We're going to go ahead and stop here in a second. All right, we're at 86. All right, 3, 2, 1. Close the poll. I'll share the results. And this is, you see the dilemma of a teacher. 25% saying too fast. 25% are saying too slow. 42% saying just right. All right, sorry. Ideally, I'll try to slow it down a little bit. I'd rather have more people complain I'm going too slow than not fast enough. Okay. All right. Now, if you wrote out, here again, this is what the variable looks like. I'm putting everybody's hands down. You've got int, that means integer. LED pin, look at the uppercase of the P, equals, that's 11. You could have been 12 though. And then don't forget the semicolon. Okay? So that's how we do variables. And we've been talking about semicolons and the line of a code. These are containers and commenting. Okay. So now I want you to go ahead and take a minute here And what we're going to do, you already have it like this, so I'm not worried about that LED. Again, this is a second lesson we would normally do. I'm going to run through that. Now I want you to go ahead and here is the digital, so we can read out pin 9, pin 10 of your breadboard. These are the LED. You can see they have polarity, they have direction. Here's the resistor. In this case, it's 330 orange. You can see it looks like this. And there's your ground. You can share a common ground here. So if you would, get out another LED, another resistor, and another lead. Hook one to 10, hook one to 9. I'm going to put everybody's hands down. Raise your hand once you've got this hooked up this way. And those of you who get it hooked up and want to, you've got that LED blink program on yours. It probably should say blink your name. So blink Bob, blink Tom, blink Annie, blink Julie, whatever. You might want to say, in this case, blink 2 lights. So rename it, resave it, save it. You can either save it already as blink your name. Make sure you keep a copy that works. Whenever you're going to make changes to code, always have the copy. So if we make some change, it doesn't work anymore, you can go back to that original copy. If you're feeling good, bring up file new and save that one as 2 blinks or blink 2 lights. If you're still learning programming, take that code blinking 1 light and then save it a second time as blinking 2 lights. All right. Get your hardware set, do that, and then see if you can make the 2 lights blink. I'm going to walk you through that in a minute, but I've got people with different abilities here. So those people are saying, I think I can make 2 lights blink. Go ahead and do that. We'll try to get the 2 lights, and then next week we'll begin to show you how to use loops to do a bunch of LED lights. And then we will use arrays to do a bunch of different LED lights, but not necessarily all in the same order. And you'll be able to make your LEDs sleep like they do on a MacBook, or when you turn a modern car on. If you turn the lights on, the lights in the interior of the car don't come instantly on. They warm up. And then when you turn them off, they slow down because it's more like our eyes are used to. We live in an analog world for the most part. Again, like I said before, if you have no intent of building the LEDs because you don't have the hardware, or you're not really going to use the Chrome and do 1, 2, 3D circuit, raise your hand so we don't wait on you. For everybody else, I'm waiting to see you get to the 2 LEDs. Don't raise your hand if you have the software written. I'll walk you through the software. But raise your hand when you have that hardware hooked up. Be it virtually or be it physically, you have the hardware. Okay, excellent. Let's go ahead and go on now. Notice pin 9 and 10 go through the anode. Remember, that's the positive leg of the LED. It's the bent leg if you see some other diagrams of LEDs. Going in the ground, going back through the resistor into the ground. These guys are sharing the same ground. They have separate positive sources, separate power sources. Okay. Now let's go through something real quick. When we just did our last program, we did that variable up at the top. We did void setup, where we made LED pin as an output. Then we had a void loop, and that's where we changed the state of that digital pin 13. We would turn on high, we would wait a second, we'd turn low, we'd wait a second. Okay. Now, hang on real quick. And we did that, and there it is. Now, let's add the second. Let's use the same structure and add a second LED. We're going to go a little bit, maybe a few minutes over tonight, folks. Please bear with me. All right. So the first thing we would need to do is maybe now redefine our LED variables, because we got more than one. So we might have integer LED pin 1, integer LED pin 2. So we're saying we have two LED pins. You could have made them LED pin 9 and LED pin 10 too, by the way. But by doing it this way, pin 1 and 2, we can change these numbers anytime and use different pins. We don't have to change it at this point. We won't have to go through the whole program. So if you have LED pin 1, 9, pin mode LED pin 1 is an output, what would the other one that you would need to do there? We've got one as an output, but don't they both need to be outputs? So if you can, write that code in there and write what you think the void setup should look like. You need these two variables, and then you need to see what the void setup looks like. You've defined the two variables. Write in the code or write a sheet of paper and figure out what you think the void setup would be. And once you think you have, raise your hands. And this, you don't have to have hardware or anything. You can still think about it and tell me, yeah, I think I know what it should be. And if you want, you can even write it down and give it to me there. So raise your hand once you have it. No. Hayden. No, there's really not. Hayden's asking, could we have pin mode? He's asking, can we have multiple arguments? And in this case, not that I'm aware of, no. So we'll have to use the power of the loop to help us out on that. Raise your hand. All right, if you got it done. I'm going to go ahead and move on with this because I can show you it's only about one line of code. All right, so here's what happens. We have pin mode LED pin 1 output, pin mode LED pin 2 output. So both those pins have to become outputs. Right? Again, a computer is stupid as a stick, and every time I say that, sticks everywhere get mad at me because they know they're smarter than a computer. It does what you tell it to do. It doesn't do what you want it to do. Now, it can do it very fast. That's what makes computers so incredibly amazing. But it's going to do exactly what you tell it. Would pin mode, do you have to actually have these lines of codes? No, but it would only produce 3 volts if you try to turn it on. This way you get the maximum 5 volts. All right? Now, what would you need to do to put in this void loop? I'm going to put your hands down. Looking at our void loop, we just want to make both LED lights blink. Once you have one blinking, make them blink alternatively is a kind of a cool thing to do. But in the beginning, let's make them both blink at the same time. All right? Sorry, you can hear my computer backing itself up here. I'll give you a second to try to do that. Raise your hand once you have it. If you think, you know what, hey, Mr. D, I got this thing covered. I'm just smacking it around. Excellent, Daniel. All right, you guys are picking it up. Well done. Well done. Okay, so this is, I'm hoping, and if you're doing it digitally, I'm hoping you're getting the same answer. It looks like this. All right. Digital pin 1 high, digital pin 2 high, delay a second, digital little LED pin 1 low, LED pin low, pin 2 low. All right. Now, can you figure out a way to make them alternate and blink? So when one's on, the other one's off. Raise your hand once you can do that with it. I find it most amusing, and I've been doing robots for years and everything else, and students, even people have done first projects, all these very exotic robots, there's still always something cool about turning LEDs on and off. So, so this is what I'm saying. Let's see how well you understand this. Can you make it so it alternates? You really only need to change just a couple words on this code. You don't even need to change lines of code. You just need to change your functions. And then I'm going to leave you with a bit of homework, and we're going to talk about what we're going to do next. I'm going to jump to something. I'm going to show you where we're going with this, and then I'm going to leave you a little bit of homework to try. All right. So we got 5 people. We got 5 people saying they think they know how to do this. Because it is 9 o'clock, I'm going to go ahead and make the suggestion. If you have digital right LED pin 1 high and you made digital right LED pin 2 low, high, low, this one would be on, this would be off. Wait a second, turn pin low, but then turn pin 2 high, they would flick, they would alternate. One light would be on, one would be off. They'd go back and forth. All right? Now, let me show you where we're going here. Can I have everybody's attention? I need everybody's attention now. Let me show you where we're going with this. And I'll start sending out messages reminding you Monday and Tuesday to try to set your hardware up so we don't have to wait for you to hook up your hardware when we get started. All right. Let's talk about this. We're going to do multiple LEDs. And when we start to do that, you're going to see, and we're going to go right to it, you're going to hook up so it looks like this. It's not hard. It's just going to be a little time consuming, okay? So you're going to take all these, and we're going to fix all these LEDs. But I hope you start to think about it. If you start programming this, we can't keep doing what we're doing here, where we're just going to do LED pin 3, LED pin 4. Look what the code starts to look like. That would be just to define the variables you needed. And that's why we're going to start to use loops. If we don't, you get into something, you have this problem. Look at all the pin 2, 3, 4, 5, 6, 7, 9, all output. Yeah, you can cut and paste, but that's not really practical. I can do a loop with just this much line of code, and it does the same thing as up here. So the next focus will be on looping, because as I say this as a programmer and other things, we are a lazy group if we can. If we can figure out an easier way to do it, we'll figure it out as fast as possible. My friends would say we are efficient. Okay, whatever. So that's what we're going to do. And it's just poor code, by the way, to do this. All right? Now, the homework I want to leave you with is this. So really, I guess 2 pieces of homework. Can you make a traffic light? Use your existing LED setup. If you've got a green LED, great. If you're not, you got yellow and red, then use just a different one. You understand what you're trying to do here. Can you make a traffic light using an existing LED setup? So you got to add a 3rd light, so you need to add a 3rd LED and a 3rd resistor, and you got to connect it to one of the pins. I'll give you that much hint as far as the physical. Can you program it so it does that? All right? And then we're going to try to set up these LEDs before the start of class. If you've got your hardware at school, try to convince your teacher to let you bring it home. Or rewatch this recording at school with some hardware so you can build it as you're going along, okay? Any questions? And yes, in the PDF for this is the answer, but don't look at the answer without trying to do it. You're never going to get there.